This is Mr. Hill with another linear relations tutorial. By the end of this video, students will apply data management techniques to investigate the relationships between two variables, demonstrate an understanding of a constant rate of change, and its connection to linear relations. Students will connect various representations of a linear relation and solve problems using the representations. Some of the specific expectations that we'll be looking at will express a linear relation as an equation in two variables using the rate of change and the initial value. Describe the meaning of the rate of change and the initial value for a linear relation arising from a realistic situation. And what we're considering is the rate the height changes of a burning candle. We will carry out an investigation or experiment involving relationships between two variables, including the collection and organization of data using appropriate methods, equipment, and/or technology. So our sample problem here, we're continuing with the case of the candle burning, and we're going to continue to investigate how long candles burn. Through our investigation, we'll come to discover which candle is the best for Catherine's party. So let's read the problem once and we'll read it again to highlight some of the important information. So Catherine is hosting a party where she wants to buy a few candles to add a little ambiance to her apartment. HomeSense carries two sizes of candles. The small candle has a diameter of 6 centimeters and the big candle has a diameter of 12 centimeters. She thinks her party might last about 8 hours and she doesn't want the candle to burn out. Which candle should she buy if she wants it to burn for the entire time of the party? Remember, the height of a burning candle is represented by the equation h equals 2d minus 2t, where h is the height in centimeters, d is the diameter in centimeters, t is the amount of time that the candle has been burning in hours. So how long does each candle burn, and which candle should Catherine buy? Catherine is hosting a party and she wants to buy some candles. There's two sizes of candles. The small candle has a diameter of 6 centimeters and the big candle has a diameter of 12 centimeters. Party will last 8 hours and she doesn't want the candle to burn out, so we say that it has to burn for at least 8 hours if she wants it to burn for the entire time. So which candle should she buy if she wants it to burn for the entire time of the party? We had this equation that we saw in the last video, h equals 2d minus 2t, and h once again represents the height, d the diameter, t is the amount of time in hours. And so one of the things that we need to see, we need to see how long each candle burns. And then once we know how long each candle burns, we can decide which candle Catherine should buy. A good strategy for many math problems is to make a really nice sketch of what the problem is asking you. So let's go ahead and sketch these candles. And you know what? It's always fun to be as creative as you want to be. Remember in the video how we dealt with this problem of having three variables. The problem gave us some really important information. It gave us the diameter, which allowed us to make a quick substitution and come up with a new linear equation where we could easily see our initial height, our initial value, and our rate of change. So let's see if we can do that with this problem. Remember, we're dealing with two sizes of candles, one small candle and one big candle. The small candle had a diameter of 6. And the big candle had a diameter of 12. Let's use this information to come up with two linear equations. So if we make a quick substitution for our diameter equal to 6, h equals 2 times 6 minus 2t. And this simplified down to h equals 2 times 6 is 12 minus 2t. I think it's a good strategy to keep it in the form of y equals mx plus b, and so h equals minus 2t plus 12. And then it's really easy to see that our rate of change is equal to minus 2, and our initial height is equal to 12. For the bigger candle, our diameter was 12. So I can make my substitution in brackets, and I get the equation h equals 2 times 12 minus 2t. h equals 2 times 12 is 24. Minus 2t. h equals minus 2t plus 24, where our rate of change is equal to minus 2, and our initial height for the big candle is 24 centimeters. So let's begin this investigation. Let's start with the small candle. Do you remember what t represents? Yeah, you're right, it represents the amount of time that the candle has been burning in hours. At the beginning how long has the candle been burning? It hasn't been burning at all. So our time is 0. So I can go ahead and I can make my substitution. Minus 2 times 0 plus 12. So minus 2 times 0 is 0 plus 12. And our answer, 0 plus 12 is 12. Now, as I increase the time by 1 hour, what happens to the height? I can make my substitution. Minus 2 times 1 is minus 2 plus 12. 12 minus 2 is 10. Now, I want you to take the time to notice this. How do we get from 12 to 10? We subtracted 2. Remember, our rate of change was negative 2. But when we're dealing with linear equations, we can use that rate of change to quickly come up with the numbers in our table. As I increase the number of hours by 1, I can decrease by its rate of change, which is negative 2. 10 minus 2 is 8. Increase the number of hours by 1. 2 plus 1 is 3. 8 minus 2 is 6. Add 1 minus 2. 6 minus 2 is 4. Add 1. 4 plus 1 is 5. 4 minus 2 is 2. Add 1. 5 plus 1 is 6. And 2 minus 2 is 0. What has happened here? After 6 hours, our height is 0. So what does that mean? It's as short as it can get. It is 0 centimeters tall. So how long has the candle been burning when the height is 0 centimeters? Well, it's been burning for 6 hours. So the small candle will burn for 6 hours. This is quite a bit of work, but is there anything that we can learn from this information right here and maybe approach the second part of this problem in a different way so we don't have to go through this whole process of creating a big table? If you remember back to our tools, these equations are very helpful to us, and so is this information. Let's see if we can use this equation and use this information to figure out how long our big candle will burn. So for now, I'm going to go ahead and I'm going to move this big table out of the way. And let's start by writing down our equation. H equals minus 2t plus 24. Now, what can we learn from this information down here? How long will this candle burn? Right? Another way we could ask this question is what is the value of t when the height of the candle is 0? If I was going to apply that up here, if I write down my variables, I know that h is equal to 0, and my t is what I'm looking for. What happens when I substitute this information into my equation? I get 0 equals minus 2t plus 24. Now this is something that we have seen this year. It's a two-step equation, and we can solve for the value of t. My first step is to isolate this variable t. I want t by itself. I'll go ahead and I'm going to rewrite this equation again. So if I want to get rid of 24, I have to subtract 24. Whatever I do to one side of my equation, I have to do to the other. 0 minus 24 is minus 24 equals minus 2t, and 24 minus 24 is just 0. Now I can go ahead and I can solve this equation. So I have multiplication. And if I just want t by itself, I have to undo that operation. And the only way to undo that multiplication is to divide. So what do I divide by? Well, I always divide by whatever's attached to our variable. So I'm going to divide by what number? Yeah, you're right, minus 2. Whatever I do to one side, I have to do to the other. Minus 24 divided by minus 2. Well, negative divided by a negative is going to be a positive number. And 24 divided by 2 is 12. Negative divided by negative is going to be positive. 2 divided by 2 is going to be 1 times t. So we're left with 12 is equal to 1 times t is just t. So now we know that our big candle is going to burn for 12 hours. Let's revisit the problem. So now we can come back to our original question, how long does each candle burn? From our investigation, we found that our small candle burned for 6 hours. And our big candle burned for 12 hours. Which candle should Catherine buy? Remember, Catherine's party will last up to 8 hours. After we did all this work, we see that our small candle will not burn for the entire length of the party. So we need to buy the big candle. So I hope it's easy to see how you can use math to solve real problems.